Xometry's manufacturing technologies explained. Fused Deposition Modeling is an extrusion-based process that creates plastic parts by extruding melted thermoplastic material through a nozzle. It is one of the most widely accessible and used additive manufacturing technologies due to its simplicity and cost-effectiveness. Industrial FDM printers are larger and more precise, capable of using advanced materials with high strength and thermal resistance. They often feature heated build chambers and high-performance extruders for optimal quality. In contrast, desktop FDM printers are smaller, more affordable, and typically used for prototyping and hobby projects, offering good quality but less precision and material capability. FDM primarily works with thermoplastic filaments, available in a variety of colors and materials such as PLA, ABS, PETG, and TPU. Additionally, engineered plastics like PC, nylon, and ULTEM are also commonly used in FDM for more demanding applications. An FDM printer consists of a printhead with a heated nozzle, a filament feed system, a build platform, and a motion-controlled system used to precisely move the printhead and build platform along the X, Y, and Z axes. Fused deposition modeling works by feeding a thermoplastic filament into a heated nozzle, where it is melted. The printhead moves according to the part's cross-section, depositing the melted plastic onto the build platform. This technology often requires a support structure, particularly for overhangs, which the nozzle prints alongside the part itself. Many industrial printers can deposit more than one material, such as the part material and a soluble support material, to ease post-processing. After a layer is deposited, the print bed moves down, or the printhead moves up, and another layer of filament is extruded onto the previous one. The process repeats until the part is complete. Finally, the completed parts are removed from the build platform, and any support structures are detached. Further finishing operations, like installing threaded inserts, are performed when necessary. Let's recap what we've learned from this video. Parts produced are rigid, functional, and cost-effective, ideal for concept models. FDM printing has a wide range of thermoplastic materials. It has large build volumes. FDM 3D printing is good for rapid prototyping. Xometry, where big ideas are built.